There is a number called e, which is about 2.718, an irrational number, and it comes up in math in a lot of different places. One way to estimate e is to take a number like 1 plus 1 over 10 and raise it to the 10th power, and you'll get something between 2 and 3. I don't have it handy. The bigger you make this number, the closer the answer gets to e. So as long as this number equals that number, so we can say that e is sort of 1 plus 1 over x to the x power as x gets really big. That's how you say it in math. And you can plug in different values and see that you will get close to this 2.718 number. Another way to get e is to use this formula, where 0 factorial equals 1. And you could try it yourself, plug in, you get 1, this is 1, this is a half, this is a 6, and even just from that we're getting kind of close to 2.7. The more terms you do, the better. So those are two formulas for e. If instead of putting 1 on top, I put 2 on top of the first one, 1 on top of the first one, 2 on top of the second one, 4 on top of the third one, 8 on top of the fourth one, it's actually going to get very close to e squared. Take away that e. And in general, the formula is e to the x is equal to 1 plus x squared over 2 factorial plus x to the third over 3 factorial, going on. So if you want to know e to the fifth, you can plug 5 into this formula. If you put negative 1 into the formula, you get 1 minus 1 plus 1 half minus 1 6 plus ... And that is going to be relevant for another time. These formulas seem so unrelated. You have the 1 plus 1 over x to the x power, and that's equal to, they're saying, 1 plus 1 over 2 factorial plus 1 over 3 factorial. I want to show you why it is that this thing is equal to that. If I make x 100 and I do binomial expansion, I get 1 to the 100th plus 100, that's 100 C1, times 1 to the 99th times 1 over 100, plus 100 C2 is actually 100 times 99 over 1 times 2, or 2 factorial, I'll leave it as, times 1 to the 98th times 1 over 100 squared. And what ends up happening is that this 100 squared is fairly close to this 100 times 99, and this 100 is equal to this 100, and these 1 to the 99 is just 1, and 1 to the 98th is just 1. So when this whole thing cleans up, it just becomes 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial. Because at the bottom of any combination, there's going to be a factorial, like 100 C5 is 100 times 99 times 98 times 97 times 96 over 5 factorial. So when you get to the 96th term or whatever, these guys are going to cancel out with the 100 to the 5th, and all that's going to be left is this 5 factorial. So that's why these two formulas get you the same answer. Binomial expansion, something you want to review.